Okay, so welcome everyone to the SI session. So again, this is an alternative virtual SI session. So I'm gonna have to keep you guys on mute the whole time, but we'll use chat for the purposes of talking to each other. Yeah, again, I was just asking you guys, how are you guys doing? I know we just had like a midterm and now we're gonna get finals soon this month. So how are you guys feeling with all of what's going on? Okay, so while you guys are adding the answer in the chat, I'll just go over the agenda real quick. So what we're going to do today is I have prepared like 6-word problems, and these are similar to the final review that you guys are going to eventually get. And these problems are the ones that Dr. Tran did in the past week. This is where we will be doing weight percent, mass over volume percent, and then volume over volume percentage. And we'll work on molarity a little bit. And then if we have time at the end, we'll do a little bit of concentration problems. This is something that you are going to focus a lot more in the lab. Since I guess you guys have like a project due, which is an independent project. And then just a reminder that my next session is going to be on the 5th of May. It's going to be on a Wednesday from 2:30 to 4 p.m., just a regular time. But let's go to the icebreaker for today. It's very simple, but I need you guys to be familiar with the vocabulary. So for the icebreaker, I need you guys to define these 3 terms, first of all. So what is a solute? What is a solution? And what is molarity? For molarity, you can just put like the formula for molarity. And then how do we get rid of percentage? If I tell you that I have 50% of something, how can you get rid of that percentage to get like a normal number? So work on this independently. I'll give you guys like 5-6 minutes. And once you're getting the answers, just put them in the chat and then we'll discuss it together. Yes, it will be the whole thing together, right? When you mix it, it's going to give you a solution. Okay, so just like you added in the chat, solute is just a minor component, right? So we can write, this is just a minor component that we have in our solvent. And then our water is our solvent. And when you mix both of them together, so water plus NaCl, then you get a solution. Okay, so is this clear to everyone? Basically why I wanted to go over this particularly is you could get to like some definition term questions in the exam, but also when we do word problems, they're going to refer to these words so often. So make sure we know what each of them means and then how we can apply it into the formula. Okay. Does anybody know the formula for molarity? The hint is it's something over something. Okay, if you guys don't yeah, it is N over V. So basically what it means is moles over volume, or moles over liters, let's put it that way. Okay, thank you. And does anybody know how do we get rid of a percentage? So if I had, for example, 50%, what do I have to do to get rid of that percentage and get just a basic number? Okay, it's okay if you don't know. So basically what you do is you divide it by 100. So this is something that you're going to have to do a lot in the word problems. So you just divide that. And then for example, if you have just the number like that, and you want to convert it into a percentage, you multiply by 100, and then you get the answer. So kind of like that. But we will utilize this information in our word problem. So let's just go ahead and do that. So these are a few of the problems that we have. We'll just go over them one by one. So the first question is, how many grams of potassium hydroxide are in this much? So 200 grams of, and then they give us the percentage of potassium hydroxide solution. So for this problem, we are looking for the grams of potassium hydroxide. So what do you guys, which formula do you guys think we would be using? And the clue is over here. Basically, first, for this problem, we have to get rid of the percentage. Whenever they sometimes give you a percentage, you want to get rid of it. So let's try to get rid of that percentage. So like we went over, when you have a percentage, you do what? You divide it by 100, yep. Okay, now this is going to get rid of that percentage that we have. So what did you guys get after this? And then now we have, yep, this is what I got too. So 0.2. And then we'll just put a 0 here so that we have like the correct amount of sig figs. So here you go, that's your answer. Now the second one is using this formula like you guys mentioned before. So now it's easier for us because it kind of tells us which formula to use. So for this one, they want the percentage. So make sure when they say they want the percentage, you know that you have to convert the answer into a percentage, just like we went over in the formula. And here they're saying volume over volume. So let's read the question and see what's going to be on top and what's going to be on the bottom. So they're saying, what is the percentage, volume over volume, of 200 milliliter of a solution containing 15 milliliter of alcohol? So make sure you know you get what? It would be 7.5% of alcohol solution, right? Okay, are these problems kind of making sense now? If you guys have any questions about any of them, please do let me know. I guess I found another way to do like the first problem. You can use whichever way, but the answer is going to be the same. So remember how we talked about M over V? You could just put 200 grams here, and then we are looking for the grams. And then you just put 0.10 over 100. And then you just cross multiply, right, to get the x, which is still going to 0.20 grams of KOH. Now, this one is just the abbreviated way. And this is just, you can see that it's mass over volume, because this is my mass, this is technically my volume, and then you get the answer. Okay, so any questions about 1 or 2 before we move on? You can show me a thumbs up if it's making sense. If it's not, we'll clear it out. Okay, if it's making sense, good. Okay, now let's go over the third problem. So in this problem, they're saying that normal blood contains this many, so it's 9.0. I don't know if it's, the point looks a bit weird. Okay, it's 9.0 grams of sodium chloride per liter of blood. What is the percentage of sodium chloride in normal blood? So now they didn't technically give us the number for the blood, right? They just told us that you have a blood. So let me try to draw this. Like, this is how I learned chemistry, honestly. For example, this is my normal blood, okay? And they're saying that I have 1 liter of it. In that blood, we have sodium chloride, and we have 9.0 grams of it. Now they just want to know the percentage of NaCl in that normal blood. So from here, you'll have to understand which one is my solute, which one is my solution, and then you have to convert it into a percentage. So it's basically the same thing as before. So can you guys tell me what's my solute and what's my solution? So my solute indeed is NaCl. So it would be 9.0 grams of NaCl. And what is my solution? And they said I have 1 milliliter, so we're gonna have to, no, they said we have 1 liter, we're gonna have to convert it into milliliter. So what would it be? So when we have 1 liter, let's try to do the conversion here. So how many milliliters are in 1 liter? 1 liter has how many milliliter? I know, again, this is from like beginning of the semester when we did the equalities. Yeah, so it is going to be 1,000. So when we are converting, do we put the 1,000 on the top or the bottom? On the top, right? And then we put 1 liter on the bottom so we can, cancel it out. So in the end, how many milliliters of normal blood am I going to have? 1,000. Yep. Okay. So make sure you like keep working on these problems. Like they're from the beginning of the semester, but they're still going to be used to this date. Okay, so now we have the solute over solution, right? So what do we get? Okay, so now we have this number. We have to convert it into a percentage. How do we do that? Yep, multiply by 100%. And what did you guys get for the final answer? Percentage of NaCl in normal blood. Wait, is this clear for all of you guys? So basically it's more of like a plug and chug method. Just know a few things such as solute over solution. Make sure you know how to identify the solute and the solution, and then know how to convert from a number to percentage and from a percentage to number. So in this problem, number 4 that we have, we are going to be converting percentage to a number. So let's look at it together. I'm gonna ask you guys to do it on your own, like the whole problem, but we'll set up together and then we can talk about anything that we don't get to. Okay, so the question is, normal blood contains this percentage of mass over volume, and how many liters of blood contains 2.0 sodium chloride? So we're still working with blood and we're still working with sodium chloride. So we kind of already know our solute, right? And our How are you guys doing with the problem? It's like based kind of like algebra. I know it's been like a long time, so it may not be as easy as we think. Wait, let me look at the solution that I did last night. Yes, the answer is close. Can you put it into two sig figs, because in our question we have like two sig figs for both of the numbers. So what would it be in proper sig figs? Okay, we can do it together, but your answer does look right. We just want to put it into like the two sig figs. That's about it. Okay, so in order to do this problem, we're gonna have to do cross multiplication. First, we get rid of this percentage that we have. So in order to do that, you just divide it by 100, right? Like we have been doing before, and then you get something like this. And then you copy down the whole thing like we have it on the top, and then you do cross multiplication, right? Here you can put 2.0, and here you can put 0.009 in parentheses 2.0 plus x. And then now we have, if you guys remember from algebra, we do this distribution method, right? Whenever you do this, you basically multiply. So we'll copy this down. And if you multiply this by this, you get 0.018. And then when you multiply this with just the x, you just get the whole number and x. Now, in order to get the x by itself, first we have to subtract this number from both sides. And here you get 1.982 equals 0.009x. Now, in order to get x by itself, you divide from both sides. And in the end, you do that, and your x comes out to be something like 2 to 0.22 milliliter. But again, we don't want the answer in milliliter. They're saying how many liters, right, in the question. So make sure you answer it just as the question asks. So you get this milliliter. Now you convert it into, liters. So you're gonna put 1,000 on the bottom so we can cancel out the mLs, and then 1 liter on top, and therefore you get 0.22 liter. And I cut it off at 22 because that's the two sig figs we need. So how did you guys do with this problem? Did it make sense? Any questions about any of what I did here? Just take a minute to go over it and see if you understand it fully. And give me a thumbs up if you're good, so we can move on to the next problem. Are we good, guys? Yes, no, maybe so. Yes, okay. Looks like both of you guys are good. So let's work on this problem. It's okay if you are not able to get to the last problem. Okay, so for this problem, they said dissolve 62.1 gram of ethylene glycol. So we have grams and then grams of H2O. So again, to put it into perspective, you have H2O, and then you have glycol ethylene. We don't really need to know the formula of it, so it's fine. You have this much of glycol ethylene. We'll just put glycol in the water. So make sure you know what is my solute, what is my solution. And then you want to get the weight percent, which basically means you want solute over solution. That's about it, grams over milliliters. No, actually grams over grams because it's weight. And then, so here, let's first put solute over solution. So what is my solute here, guys? And there is 250 grams of H2O. Yep, glycol, so it's 62.1 grams, right? And guys, what is my solution? So they're not asking for solvent, they're asking for solution. And again, just a reminder, solution is solute plus solvent. So give me the answer in like numbers. What would it be? Basically what you do is you do 62.1 plus 250 because that is my solution, right? Solution is both of them combined. Okay. So first you're gonna have to do this, find the answer for this, and then they want the answer in percentage. Therefore, you'll be multiplying by 100%. So what did you guys get for the answer? Actually, let me do that. Okay. It's close to what I got, but let's keep the answer in 3 sig figs because 3 sig figs and 3 sig figs. So what would it be exactly? Yes, that's exactly what I got. Yep, so basically once you put this into the calculator, you get 0.199, you multiply by 100%, and you get 19.9%. Here you go. And that would be the weight percent of glycol. Okay. Is this clear to the both of you? Okay. Sounds good. We technically have only 4 minutes. Do you guys want to do the molarity problem? Or should we wait until Wednesday? Basically, for this problem, it's pretty like easy. For this, you just look at the formula. Molarity is moles over liters. Here they have given us the molarity and the grams, and we want to look for the volume. So it's going to be molarity is mole over liters. We have the molarity. We don't know the moles. We don't know the liters. But can you guys tell me how we can get from the grams of KCl to moles? And this is from like the second midterm when we were doing mole conversions. Yeah, so gram and molar mass. So let's do it together. So 15 grams of KCl. And then what do I put on the bottom? Can you guys look for that number from your periodic table? Basically, 1 mole of KCl has how many grams of KCl? Yes, that's what I got to, 74.5513 grams. It's 1 mole. And then what did you guys get for the moles when you put it into the calculator? Yeah, this is what I got too. But just because we are not at the end of the answer yet, I'm not going to round it off. So I'll just put the whole answer so we don't miss a lot of numbers. That's what I get in the calculator. But we still have to put it here. So let me copy paste that. All right. So see how we went from grams to moles, and now we're gonna look for the liters. So there is like a step that we have to do. So find the answer here. So what do we do to get the liters? Since we don't have much time, I'm just gonna kind of put it into perspective. Oops. And this was the amount of moles we had. And to get X by itself, you just divide from both sides, right? So can one of you guys put it into the calculator and tell me what you got? Yeah, that's also what I got. But again, guys, let's not forget that we have to put everything in sig figs. So this is 4 sig figs. So what will be my answer? See, this is 4 sig figs. This is 4 sig figs. So our answer has to be 4 sig figs. Okay. I got 1.817. That's basically close to what you guys got, but this number is different. So make sure when you're putting in the information, you put like the whole number, like this one. Because if we had just put like 0.20 divide by 0.1107, our answer is slightly off, and we can't have our answer as 1.806. That's way off, right? So we put the whole thing for those purposes. Oh, is that what you guys got? Let me put it into the calculator again. Maybe there's a difference between like the molar mass. So if this molar mass is from your periodic table, then it will be different. And then if it's from the Google search, then it will be a bit different. So those numbers can cause like a difference, but make sure you stick to your molar mass. I don't know if this molar mass is from the periodic table, but we can discuss this on Wednesday as well. We'll do a lot of like these kind of problems. And we'll go into like KC expressions, all of that kind of stuff next week. But basically for the closing, I'm just gonna wait for like a minute or two to see if you guys have any questions. And also put in the chat what is like your main takeaway from the session. There's a lot that we went over. There's a lot of formulas. There is a lot of things that you have to keep in mind when you're doing these kind of problems. So what is something that like either made more sense or something that you learned completely today? Yeah, knowing what is my solute and solvent, like I really like to draw these kind of pictures so that I know exactly what's happening, because in the lab you can see these kind of things. But when we're working on problems like this without the lab component, it can be a little tricky. Okay, any other things? I will send you this worksheet, but you can like zoom it. I know it's small, but you can zoom it from your laptop. And if you took notes, that's great too. But I'll see you guys on Monday in lecture. I hope you guys have a good weekend, and bye everyone.